Hallo, dieser Podcast wird Ihnen präsentiert von der Hannover Messe. Viel Vergnügen beim Zuhören.
Hallo, liebe Zuhörerinnen und Zuhörer. Das ist die Podcast-Folge Nummer 37 des Podcastes KI in der Industrie. Mein Name ist Robert Weber und ich präsentiere euch heute eine Kurz-KI-Folge. Und zwar habe ich mit dem Victor Schmidt gesprochen. Victor kommt aus Montreal und arbeitet bei MILA, also eines der wichtigsten ML-Institute der Welt. Und ich habe mit Victor Schmidt über ML und Carbon Footprint gesprochen, weil die da in Kanada sehr spannende Forschung zu dem Bereich machen. Entschuldigt bitte mein Englisch. Wir haben mitten in der Nacht aufgezeichnet, wegen der unterschiedlichen Zeitzonen. Trotzdem wünsche ich euch viel Vergnügen und einen interessanten Podcast. So maybe you introduce yourself to the listeners.
So my name is Victor Schmidt. I'm a PhD candidate at MILA with Professor Yoshua Bencho. I work mainly on topics related to climate change and AI. The three main topics I focus on are how we can help people better understand the consequences of climate change through AI-generated visualizations of potential consequences like floods in one's home. There's this project that you know of about providing tools to the AI community to measure and report their carbon emissions. And the third project I work on focuses on using generative adversarial networks to help model the clouds in our atmosphere to help climate modeling.
Okay, and you are based in Montreal, is it right?
Yes, in Montreal, in the new offices of MILA, which moved last year.
And now you invented, together with your colleagues, a tool that measures the carbon footprint of machine learning. Maybe you can explain your tool.
The goal of this tool is to enable people to compute the carbon emissions of their computations. The way it works right now is you only need to input the type of GPU that you use, the number of hours for which it has run, and in which area of the world, and it will compute the CO2 emissions of your calculations. The two things that...
And the calculation?
That's what I wanted to explain is how it works. The main thing that we wanted to emphasize is that the localization of your computations matters a lot because not all grids have the same carbon efficiency, which means that basically running a GPU in Quebec or in Iowa, as we illustrate in the paper, can generate up to 40 times less carbon. Even though cloud providers offset their emissions, offsetting is not emitting, right? And it's less certain, and it's in the future. But as we know, the inertia of the climate system makes it very important that we limit our emissions right now. Even though we can offset everything for the future, we need to have lower emissions right now. So that's why we have this tool, and we're currently working with a team out in Pennsylvania in Haverford College. And they have built a Python package that can automatically measure this and provide you the carbon emissions of the computations. And so together our two projects aim at enabling people and the machine learning community, AI community, with better and more informed reporting on their computations. One last thing is, in the tool that we have built, there's also a LaTeX generator. So the research community uses LaTeX to write their papers. And so if you input your computations into our tool, we will automatically generate a LaTeX paragraph that you can add to your paper. And we want to support the community towards more reporting and more transparency. And so that's currently where we're at.
Where and how do you collect the data for the project?
That's the hardest thing, to be honest. There is no centralized data. So there are sources for our data, and everything that we do is actually sourced on GitHub. There's an open CSV with a source for every number that we have. The main sources that we have are US agencies. It's called eGrid data. I don't exactly remember what it stands for. I can find that. But we also have, there's an organization called Carbon Footprint, and they have done some computations for some countries. There's a company called Electricity Map, and they have an NGO called Tomorrow, and they have made some data available to us. So really finding the data that basically maps kilowatt hours to CO2 is the hardest thing for this project, right? Part of what we expect is by having the community eager for these numbers, try and push for better standardization and effort towards measuring these emissions. And that's part of the effort of Electricity Map, and they're helping us. So, I mean, we're never going to get exact measurements, but we want to push for as much transparency as we can.
Okay, now you have the data, and then you train the model. Is that correct?
No, it's this is a tool for the AI community, but there is no machine learning involved in the computations themselves. The computations are actually very simple. If you select your GPU type, then we can know the average power consumption of such a GPU when it's used completely. So that maps first the number of hours that you have run your GPU for, that maps it to kilowatt hours, so energy basically. And depending on where you did these computations, we can map this energy to the carbon efficiency of the region. And that's basically a standard multiplications involved, nothing too fancy. It is very deterministic.
You're focused on the cloud providing services, is it right? Yeah.
So yes, that's right. So for now, there are 4 options for your computations. It's either one of the 3 major cloud providers, Microsoft, Google, and Amazon, or a private infrastructure, because many companies have their own clouds or infrastructure for computations. The difficulty here would be to provide users with data that would come directly to them, meaning you just input your city and we can find the number that they're looking for. So that would be the ideal scenario. But right now it's harder than it seems because there is no such data, and we're trying to create such a database, but it's harder than we expected. So right now, if you have a private infrastructure, our calculator expects that you know the carbon intensity of the region. That's not very user friendly, and it may it may change in the future, but that's what we have right now.
Do you had a contact to the cloud providers? Do they recognize your work?
So not afterwards. I mean, not like you reaching out, but we do have contact with them in general, especially because we want to build this Python package that will help users actually measure the computations on the cloud. And so creating these bindings with the cloud infrastructure and so on, not that easy. So we expect some help, but there is nothing formal right now.
Maybe you can explain a little bit more the Python package you mentioned.
What we aim for is just a one-liner, meaning you just write 1 line in your code, or maybe 2. Right now it's 2. And this package is going to monitor the CPU and GPU activity while you're running a script. So, for example, while you're training a model. And then it's going to output the total amount of energy that was used during your computations and map that to CO2 using the same kind of data as I explained before. And so one of the reasons why this is very important and we can't just rely on people inputting their GPU time is in machine learning in general, there are a lot of parameters, and we call them hyperparameters actually, that define the algorithm itself. And these parameters will not be learned, and they have to be set by humans. And one of the most energy consuming part of machine learning is actually searching for these hyperparameters. And so just measuring the final computations for the final model that you know of. So basically, if I tell you this computer vision system takes, 3 days to be trained, it doesn't say how much computations were done to find these hyperparameters that led to the final model that takes 3 days to train. And it's not a trusted figure, and it's not something there's research on, but my gut feeling is that probably 90% or even more of the total computations that we do in AI are actually wasted. And by wasted, I mean they're not the final model. They are research, they are experiments, and they are ways to understand the behavior of our model with the data, the hyperparameters, and so on. But they are not the final model. Is that clear?
Yep.
This is why we need something automatic, is because if you're going to run 100 or 200 experiments to do your research paper or to build your industry product, then you're going to lose track of most.
Yeah, we spoke about, I think 3 weeks ago, about autonomous machine learning. Is this a solution you mentioned or you focus on?
It could be, as it would probably lead to more efficient model creation, right? So maybe if AutoML works, then the 90% I mentioned earlier will go lower. But in general, it's a very different problem. And our problem is, how do we incentivize our community towards more transparency and reporting regarding their emissions, right? And one of the tools they can use is by having a more efficient approach to their computations. And AutoML can be one of these ways. But I think it's orthogonal in the way that whatever the meaning, we want people to at least acknowledge it and be aware of that impact. And machine learning has an impact, and we have to be aware of it. It's not the biggest of all industries, but it is one. And I feel like we have a responsibility as researchers and as engineers to at least acknowledge that and push for more transparency. And for example, recently, I think this weekend, Microsoft announced that they wanted to be carbon negative. I'm not saying that this is on us, and it's certainly not, but this is the kind of behavior that we want to push for.
What is the impact of machine learning on the energy and on the nature and on the global warming? Do we have numbers, or can count it?
I don't think so. I'm not aware of any research that actually measures the total impact. There is some research regarding the internet and cloud computing in general, but not AI specifically.
Yep.
I mean, one of the good outcomes of what we're working on right now would be to have more precise numbers. But I think it's in general a very hard topic, because most of the computations are done privately for companies where they research and run hyperparameter searches and design their models, and they want to protect that, and I understand why. But it would be very, very hard, I think, to have this measurement. But that's the direction in which we want to go with this reporting of emissions. So, for instance, we'd like people to have in their appendix just a couple of lines mentioning, well, we run our GPUs for blah, blah hours in this or that region. And we estimate that this created that much CO2.
Okay. And now when you establish this, then you can compare the work of machine learning on the models and the training of the models.
Yes.
And maybe it's also an economic advantage to show the customer, hey, we do it very, very fast. We do it very efficient, and we don't need much more energy than the other companies.
Yeah, I agree. And it tends to be the case very often when you actually consider sobriety in general in the way we approach technology. Is like often you realize that being environmentally friendly, so to speak, or at least aware, it actually often leads to also more economically sustainable behaviors.
And you attract employees to come in your company, huh?
Yes, and it does affect your image, both as for your clients and your teams. So,
do you think that the big tech companies, like you mentioned, Microsoft, they will go on this trip with you to measure this and to put this Python one code inside the machine learning?
I hope so. I know they have released very recently, so I haven't had the time to play around with it. But they have released a calculator, probably similar in terms of goals as the one that we have, that will help companies assess their carbon emissions when they use Azure. So hopefully this is something other cloud providers will do. And hopefully we can create this package that will have bindings toward every cloud provider's specific.
And maybe then you can compare, huh?
I don't know. It's a very new topic. There is no standard, so everything changes very fast. So I can't tell you what's going to happen in a year from now, but that's certainly the direction in which we'd like to go.
It reminds me a little bit on the search engine. You know, there are search engines that are very, very green, and but the most people are still using Google. So it's very difficult to go in this market and to show them to use a green machine learning cloud provider.
Though the main difference, I would say, is that you do get worse performance with these engines. I mean, I use Ecosia, for instance, daily, and I often use Ecosia to search for Google, right? Because I can't find what I'm looking for. I don't think that energy efficient, environmentally aware cloud providers would provide you with a worse service. So I think it takes more to use an environmentally friendly search engine because it actually costs you some time because sometimes it doesn't find the right things. Then it would cost you to just choose your cloud provider depending on the efficiency of their energy.
Okay.
So there is a slight parallel, but I don't think it's as hard. I don't know. We'll see as time goes by.
Okay, you mentioned in your introduction that you do research on this measurement, and what is the other point you are doing research in Montreal on economic effects on machine learning?
That's the main thing I do on the economic effects and things that are related to the economy. The second research topic I focus on, and actually the one I work on the most, is to create a tool that will help us better understand the consequences of climate change by creating personalized visualizations. And that means that ideally, at some point, you will be able to input your address in our system. And thanks to Google Street View, we'll be able to fetch an image of your address. And our AI system, our basically GAN-based, generative adversarial networks-based system, would transform the image to show you what your house would look like if it had gone through a flood. And we've based this approach on research showing that visuals can actually help people better understand a situation and actually change their behaviors. There's one very interesting study that's called Climate Visuals, that draws some principles regarding climate communication, and using images to which people can actually relate is one of the strong points that they make. And so that's what we want to do. And by providing you with a personalized image of what the consequences of climate change could be, then we hope that people will better understand that the urgency of action and floods are not gonna stop. They're only gonna get, well, not everywhere in the world, but in most regions where they're gonna be more frequent and more severe.
So you're focused on floods or also on fires and dry or whatever?
Yes, we've started to work on fires also. Mm-hmm. The main reason why we started with floods is that, well, we're based in Canada, and in Canada, floods are a very important topic, especially when the snow melts. Mm-hmm. So it happens every year. And also because it's very visual, mm-hmm. people can actually understand very easily what's happening in a picture when you show a flood. Showing a drought is much harder, or even smog, mm-hmm. as you can see in a lot of cities because of the pollution and so on. It's harder to visualize. Fires are very visual, obviously. They're also less widespread across the earth. We know of some places that are very famous for their fires, for their wildfires, like Australia or California or Portugal, but it's not necessarily something that people, especially in Western cities, are going to feel threatened by.
Okay, and the technique behind is you collect data, what kind of data, and you using a machine learning algorithm to how to visualize. What is the learning for this model behind?
So the thing it's learning is the framework in which we work is called image-to-image translation. And so the goal is to learn how to transform an image from one domain to the other. The basic example, and the most well-known, is how to transform a horse into a zebra. Mm-hmm. And the way it's going to work is you're going to gather a lot of images of zebras and a lot of images of horses, and you're going to basically teach your model how to learn the difference between horses and zebras. And it's only going to learn, well, there's many, many ways of doing things, but the vanilla way of approaching that is, well, if I transform the image of a zebra into a horse, and then I use a second model to do the exact opposite, then I should get the zebra I started with in the first place. So if I transform a zebra into a horse and then the resulting horse back into a zebra, then I should have the same thing. And basically that's how the models are trained.
Okay.
And for that we use GANs, which are very popular models to approximate the distribution of images.
So the carbon footprint measuring is online. Everybody can use it and can try it.
Exactly.
How long will it take to check your personal flood index, or how you call it?
Probably going to take at least 6 more months. Mm-hmm. The reason is we're going to need web development and web design, and that's not our area of expertise as AI researchers. So we're going to need to find external help. And second thing is, we want to behavioral experiments and psychological experiments, meaning we don't want to base our system on our gut feeling that it's going to work. We want to experiment and check whether or not it's going to have actual effect on people. And to that extent, we need to experiment before we even release the product, which is very close to what designer would call user research.
Okay. And so maybe in 6 months, we will talk again, Victor.
Yes, I will keep you posted. There's one more thing I'd like to mention is the flooding model that we use. As I said, it uses images as training data. So it means it's going to use images of flooded areas, flooded houses, and photographs of non-flooded houses and streets. And so the main difficulty we have today regarding the data is that there is not much data of first-person views of floods. And there is even less data that is free of any copyrights. And so that's why we had this website online that's called Climate Pics. I can forward you the address link with the podcast. But the goal is to collect data, and meaning if you witness any of these extreme events, meaning floods or wildfires, and you take a picture, basically, if you can upload them to our website, then it will help us a lot. The only thing we're going to do with it is train our model. It's not going to be released on social media or whatever. And so the website is climatepics, PIX at the end, .mila, MILA, .Quebec.
I will put it in the show notes too.
That's probably the main thing we need right now is help with people actually sharing that data.
Do you also need data from Germany or Europe or USA, Canada?
Obviously. So we're focusing on Northern America, mostly because of our localization, right? We're in Montreal. But our system is not intended to be limited to North America. And to be honest, the more diversity we have in our data, which means by including data from not only Northern America, then the better our model will be at generalizing. So yes, it is very important for us not to have only data from North America.
Okay, so I will put it in the show notes, and everybody in Germany who listen to this podcast can upload his picture to train your model.
Yeah, that would be great. And it's for research, it's absolutely never going to be commercial in any way. So basically pictures for good.
Okay, thank you very much for your time.
Thank you for your time, Robert.